Hello and welcome to this session. In this session, let us focus on transaction management, concurrency control and deadlocks. Before moving ahead, let us start with the definition of a transaction. A transaction can be defined as a group of tasks. So, a single task is the minimum processing unit which cannot be divided into further. So, this particular transaction consists of several operations, low level tasks. So, each and every transaction is divided into low level jobs which needs to be fulfilled. Until and unless all the tasks specified in a transaction are completed, we can't say that transaction is successful. Let us see the states of a transaction. So, whenever we take the instance of a transaction, either it may be active, partially committed, committed, aborted or exit. Each and every state of a transaction means something of the operation of the transaction. Suppose if you say it starts with active. So, in this state the transaction is being executed and this state is called as the initial state. Then comes the partial committed. Partial committed is nothing but if it has 5 operations and if it is running 5th operation, 4 operations are successful and 5th operation is going on, it is said to be partially committed state. So, successfully we done the 4 kinds of low level tasks and it is about to complete the 5th task. Then the next state is the failed state. Suppose if a transaction is said to be in failed state, any of the checks made by the database recovery system fails. A failed transaction can no longer proceed further. Suppose if a database part is having some sort of validation or verification checks mechanism, wherein which it is checking against some login or password of a user against the database and it is unable to move further. Why? Because the login name or the password given by the user is incorrect and accordingly it displays a message and the transaction it does not happen and it is a failed transaction. Then the next state of a transaction that can be considered is the aborted. If any of the check fails and the transaction has reached a failed state, it means that the transaction has not happened and once again a recovery manager rolls back all its write operations on the database to bring back the database back to the original state. Suppose some tasks are been happened and at some part of time the checks failed and then there we have not given any commit command. So, all the transactions till that particular end will be reverted back and then it comes to its start state. So, transaction in this state are called as aborted. So, the 2 operations after the transaction aborted are it may restart the transaction or else it completely kills the transaction. And then the next state that we can see is the committed state. So, if a transaction consists of 5 low level tasks and all the 5 low level tasks are being completed, then it executes a type of operation called as the commit operation. All the effects of updates or whatever the things that has been done during these 5 operations will be committed and permanently established on the database system. So, let us see an illustration of all these 5 states. So, this is the begin and this is the initial state we were talking about, active state. Suppose if most of the tasks are being done and if it is in the final operation, then it can be called as partially committed state. Suppose if something went wrong and the checks failed, so it may be falling on to the failed state. Once again if it is failed, either it may be aborted or else if at all the data that it is requested for is available, then it may continue and then it may finish off the operation. If at all the partial committed state, the last task is over, it can move on to the committed state wherein which a commit command may be given and the transaction will be successful. For the failed one, it may be moved to the aborted and then in the aborted state it may reinitiate the whole process, or else it will kills the transaction. So, this is how we can define the various states in a transaction. Then each and every transaction in the database system must maintain some properties. Those properties are called as ACID properties. ACID short form stands for atomicity, consistency, isolation and durability. So, commonly these four terms is clubbed to and been short form to ACID properties. So, in order to ensure the accuracy, the completeness, the integrity, the consistency, these particular properties needs to be defined on any transaction. So, let us start what is the definition of an atomicity. So, atomicity is nothing but in this is a property that states a transaction must be treated as an atomic unit, that is either all of its operations are executed or none of the operations is executed and is been thrown back to the initial state. So, if all of the operations are executed, so partly doing some of the operations in a transaction is not allowed. So, it is the definition of the atomicity. So, there must be no state in a database where a transaction is left partially completed. So, the state should be defined either before the execution or else after the execution. Then the next property that a transaction needs to satisfy is the consistency property. So, the database must remain consistent all through the transaction. Suppose if a transaction should have an adverse effect, then the database may be disturbed and it is not in the consistent state. So, no transaction should have any adverse effect on the data residing in the database. If a database consistent state before the execution of a transaction, it must also remain, we have to see it must also remain as it is in the consistent state after the execution also. The next property is the isolation property, wherein which it talks about the updates. So, in a database system where more than one transaction are being executed simultaneously and in parallel, the property is of the isolation states that all the transactions will be carried out and executed as if it is the only transaction in the system. So, it should not mix up with other transactions, and that too when parallelly simultaneously some operations are going on, it should not interfere. The first transaction should not interfere with the second transaction until and unless there is some sort of data exchange in the database from the database itself. So, it should see that it should not, the whole system should not get disturbed and no transaction will affect the existence of any other transaction. So, that needs to be taken care. Some operations of one transaction and the other operations of the other transactions may be running in parallel. However, it should not interfere and disturb the whole database itself. And the fourth property that we can see is the durability property. So, the databases should be durable enough to hold all its latest updates even if the system fails or restarts. So, if a transaction updates the data and commits, then the database will hold the modified data. It should not contain the old data, however, it should contain the latest update. If a transaction commits but the system fails before, it should rewrite or else it should be drawn back to the initial state. It should not continue in the midway or else it should not create any kind of disturbance to the updates of the databases. Then let us see how these transactions happens. So, a kind of schedule will be maintained. Suppose if it is a single user system, then a kind of schedule will be maintained and a chronological execution sequence of transaction is called will be happening, and that kind of sequential execution style is called as a scheduling. A schedule can have many transactions in it, each may be comprising of a number of instructions or tasks. As we had seen earlier, each and every transaction consists of a number of tasks. So whenever we talk about 3 to 4 instructions to be happened, so those instructions will be placed in a sequence or else scheduled in a sequence wherein which each and every transaction is meant for executing several tasks. Then comes how these particular schedules can be kept. The one way it can be kept is sequentially placed. So that scheduling mechanism is called as serial schedule. It is a schedule in which transactions are aligned in such a way that one transaction is executed first. It completes the whole cycle, whatever the task it is meant for to do, the whole cycle should be completed, then only next transaction will be executed. So this is a kind of queue up form, and one by one transaction will be happening in this serial scheduling. So transactions are ordered one after another. This type of schedule is called as serial schedule or a sequential schedule. As the transactions comes in, enters, the queue will be followed. But take the case of a multi-transaction environment wherein which there will be several sequence of transactions placed. So one transaction may not be from the same user. So different users will be interacting the system and different operations or different transactions are being ordered. So the execution sequence of an instruction in transaction cannot be changed, but two transactions can have their instructions executed in a random fashion. So suppose if a database file is been opened and one transaction is requesting for fetching up the data and the second is also waiting to fetch up the data from the same table. Then randomly both the instructions can happen at the same time. So there should be a kind of manager, there will be a kind of manager which will be looking after these particular sequencing or else execution of parallel instructions in a random fashion. So this execution does not harm if two transactions are mutually independent and working on different segments of data. So this particular thing you have to remember. Both the transactions whichever are participating in the environment wherein which a kind of concurrency is there. So if the two transactions are mutually independent, then they can work on different data segments and they can fetch the data. So there is no need of waiting and a parallel transaction can be allowed in this case. Sometimes it may be a scene wherein which the two transactions want to fetch the same data item. So one transaction needs to be stopped depending upon whatever the algorithm that is placed in the DBMS. So one transaction needs to wait and the other transaction needs to allow to happen on it, then only the second transaction can happen on once again on the same data item of the table. So that is what we are talking about, but in case of these two transactions are working on the same data, then the results may vary. So which transaction needs to allow first and which transaction needs to be allowed the next to it. Suppose for instance, let us take an example, a banking example, wherein which same time two things on the account, same account is happening. One thing is the account is consisting of only 1000 rupees and he wants to debit some check amount into the account and he has given a check to another person also. So both the things came at the same point of time. The check issued to the other person is of 25,000 and the user wants to debit first of all his account with 30,000. Already 1000 rupees is existing in his account. So the second issue of the check, whatever he had issued like 25,000 issued to the other person should wait for until and unless the earlier transaction happens, that is that 25,000 to be inputted to his account. Then only he can do the rest of the things. So in this way the operation should be controlled. Then how to control the concurrency? So we were talking about several techniques are available in order to control the concurrency. So in a multi-programming environment wherein with several programs are running and several users, multi-users are interacting with the environment and multiple transactions has to happen. So, these can be executed simultaneously. It is highly important to control the concurrency of these transactions. So, we have the protocols in order to maintain, in order to ensure the ACID properties. We have several protocols, and we can see the two protocols over here in the later part of our discussion. And then the serializability, whatever we had seen, that sequence of instructions, whatever that has to happen on the databases, that also needs to be controlled in the concurrency control. So, there are two protocols that we can consider in our discussion. One is the log based protocol and the other is the time based protocol. So, in the log based protocols, some logs are defined. So, database management systems equipped with log based protocols use a mechanism by which any transaction cannot read or write data until it acquires an appropriate lock on it, either write lock or read lock, whatever the lock, the status of the lock it has, it acquired. Depending upon the status, it can access the database. So, the logs are of two kinds. One is the binary log and the other is the shared or exclusive log. So, suppose in a holistic view, what we can say is whatever the operation, the transaction pertains, suppose if the transaction is holding the lock key of write instruction. So, with that particular help of that lock, that entry can be done. Suppose it is holding or acquired only the read lock, then it can read the data and it can't write. So, likewise you have two kinds of locks maintained, one is in the binary fashion and the other is shared and exclusive locking fashion. So, let us see how this binary locks works. A lock on a data item can be in either two states, it is either locked or unlocked. So, at the data item level, these locks are being maintained, either it is allowing or else it is unlocked. So, depending upon the status of the data item, then only the access part happens, whether it can be read or whether it can be written. So, the next category of locks is the shared and exclusive locks. So, this type of locking mechanism differentiates the locks based on their uses. If a lock is acquired on a data item to perform a write operation, it is an exclusive. So, no other transaction will be given that particular lock of exclusive on the same data item until and unless the first transaction is completed. So, this is a kind of exclusive mechanism wherein which others are not entered or other transactions can't share. And in the read locks you do not have the updates or else you do not have the write operations, however it is just reading the data item from the database. So, read locks are shared because no data value is being changed. So, there you can issue a shared lock, but in the at the time of write operation it will issue a exclusive lock to write. Then let us come to the second category of protocol, that is the timestamp based protocols. In the timestamp based protocols, it follows that timestamp may have the system time into consideration or else the logical counter as a timestamp. So, this is the most commonly used concurrency protocol in any DBMS. So, these timestamp protocols are being used very frequently in most of the database management systems when they are talking about the concurrency protocol. Then these log based protocols manage the order between the conflicting pairs among transactions at the time of execution. How to go, like transaction 1 should be allowed or transaction 2 should be allowed, or else which transaction will be having the write permission, which transaction will be having the read lock. So, these kinds of conflicting pairs are being like transacting by the log based protocols. Whereas, when you talk about the time, then which transaction came first in the queue. So, time which has the first timestamp or else the old timestamp, which has the latest timestamp. So, those particular timestamps will be looked into and then it allows the either read or write operation. So, every transaction has a timestamp associated with it. Whenever it is being ordered or scheduled, then a timestamp is being put on to, so that the ordering is determined by the age of the transaction, whether it is old or whether it is new. So, depending upon the timestamp, the transaction will be allowed to participate. So, in addition, every data item is given the latest read write timestamp. This lets the system know when the last read and write operation was performed on the data item. Like in the case of log based protocols, we had seen in one of the log procedures wherein binary was being performed, there the data item is given either locked or unlocked. Likewise, here also in this particular category, every data item is given the latest read and write timestamp, whether it is read or whether it is written, that particular timestamp is also been provided. Then let us come to a situation. This is an unwanted situation, or this situation is undesired in any DBMS. Even in the operating systems also, this is the undesirable factor. The factor that we are talking about is the deadlock situation. Deadlock is a process indefinitely waiting for a source that is held by another process. So, a transaction is in process and it requires some sort of a resource or some sort of a lock. So, that particular lock is held by another transaction, and that transaction is not releasing the lock, and the second transaction is waiting for something to happen. Until and unless that is being happened, the second can't release the lock, wherein which once again in turn the transaction 1 will be fetching and using. So, this kind of stalemate or this kind of situation is called as a deadlock situation. Let us discuss this with the help of an example. Let us see you have T0 to Tn transactions over here, a set of transactions. T0 needs a resource X to complete its task, and that X is held by T1, and T1 is once again waiting for another resource Y, which is held by T2 and it can't release Y, and T2 is waiting for another resource Z, which is held by some T0. So, here it is a kind of cyclic order, and one transaction is requesting for a resource which is held by the other transaction, and in turn that transaction wants something else. So, this kind of situation is called as a deadlock situation, wherein which the complete transaction part withhold or else stand still. Then all the processes wait for each other to release the resource. In this situation, none of the processes can finish their task. This situation is known as the deadlock situation, and this is an undesired state of any database, either it may be a database management system or it may be an operating system, whatever the system, computer system, this state should not happen. So, the transactions involved in the deadlock are either rolled back or else they must be restarted. Until and unless these two operations, either of these two operations happens, the situation grows even to worser. Then this particular situation can be prevented also by looking into the situations, by looking into the pile up or else by looking into the kind of sequence that it is maintaining, the transaction sequence, serial scheduling it is maintaining, we can prevent the deadlock also. So, beforehand the system needs to, the DBMS needs to inspect what operations are being sequenced, in which fashion it is being sequenced, and which transaction requires what kind of resource. So, these in order to predict beforehand which transaction needs what kind of resources, we can prevent the deadlock. So, in order to prevent the deadlock, there are two prevention schemes, the wait and die scheme and the wound wait scheme. So, here in the wait and die scheme, once again we talk about the timestamp. So, one particular transaction is waiting for a resource, and whichever is the old one, it procures first and the younger one will die or else killed. Once again the younger one will be reinitiated at a later on stage when the first transaction is completed and the resource is released. So, this is a kind of wait and die scheme which can be followed in order to prevent the deadlock situations. Likewise, you have another scheme called as the wound wait scheme. Once again, it follows a kind of like a timestamp mechanism. And before talking about the deadlock prevention schemes, suppose if something happened already and it is in the deadlock state. So, how to avoid? So, aborting a transaction is not always a practical approach. There in the deadlock prevention schemes, we are preventing, like we are trying to follow a kind of algorithm wherein which one process is killed, waited for, the first one the old one will like completes its transaction, then it will be the second one is allowed to take place. So, this kind of aborting a transaction may not be the situation or may not be the solution always. So, instead deadlock avoidance mechanisms can be used to detect any deadlock situation in advance. So, methods like wait for graph. So, by plotting the resource along with the state can be plotted in the form of a graph, and this particular category or method is called as wait for graph, and in that particular graph all the transactions and their resources are being mentioned, wherein which in a bulky system deadlock prevention techniques may work well. Otherwise, in individual transactions it may fail also. So, before concluding this particular session, let us have a recap what we had listened so far. So, we had started with the definition of the transaction and then serializability like sequencing the schedules and other things, and then we had seen that concurrency control part wherein which we had talked about the log based protocols, the binary protocols and the other things. And then we had seen the deadlock condition and we had talked about the deadlock prevention and deadlock avoidance. So, in the next class, in the next session, let us talk about the database backup and the recovery, how the database will be backed up and how the recovery mechanism, whenever there is a crash, how the database needs to be retrieved, or else how the acid properties can be maintained on the transactions whenever a crash happens. These particular things we can see it in the next session. Thank you.